Okay, let's start this class. Today we will talk about periodic CT signals. Do you remember what is CT signals? Yeah, continuous time signals. Yeah. Okay. This is our today's goal. Like firstly, we will review 3 classes of signals and signal transformations, and then we will try to define even odd decomposition for a signal, and then we try to define CT periodic signals. And let's try to review like 3 classes of signals. Which 3? Which 3 classes? Do you remember? Yeah, case 1, case 2, case 3. Yeah, that's right. And so yeah, what is case 1? Yeah, energy like signals. What is energy signals? Yeah, the energy signals, which means the energy is finite. Am I right? The energy is the signal is finite. And how to calculate energies? I give you the equations. Yeah, and but sometimes there are yeah, we will talk about later. And what is class 2? Power, yeah, power signals, which means the power is finite. Yeah, and the total energy will be infinite. And how about the class 3? Yeah. Otherwise, like the energy power is not finite and the total energy is not finite. Yeah. Okay. This is 3 classes of signals. And then we talk about like some quick facts. And there are like 4 different signals. And the first one you can see, which means there is a finite signals, no finite length, which means the time duration is finite. It will not infinite. And for these signals, which class? Yeah, class 1. Okay, class 1. And for the second class, it is the second class is just a periodic and finite signal, which means this signal is periodic. What does the finite signal mean? Do you remember? Do you remember what is a finite signal? Do you remember? Finite is not periodic. Yeah, we have already given it's a periodic, which means that the finite signal means the signal has finite value. Yeah, that makes sense to you. Yeah, because you can see the signal must have a value, which means these signals, the value for these signals are always finite. Yeah, and for example, the Sen function, Gaussian function, the signal's value always between -1 to 1. Yeah, that makes sense to you. Yeah, and what does this signals belong to? Which class? Which class does these signals belong to? Yeah, and the second one and the third one is just a constant or convergent signal. So, which class? Yeah, it is class 2. And I want to ask you a question. You can see, yeah, these signals here, we talk about this kind of signals, this one. For example, this one. Like this is a swap. And you can see if for the third signal, does this belong to third signal? Does this belong to third signal? Huh? The third, this signal. Huh? Because it converts to a value, right? It converts to a value, but it's not because you can see this signal should convert to C. C should not equal 0. But here, it converts to here. The value here is 0. So you just you need to remember that. Yeah, you can see. Like how about this one? Yeah, does this belong to third signal? Yeah, it is because it converts to 1, right? Which means C equal 1. It will C is now equal 0. That makes sense to you? So you need to pay attention. This one and this one. Yeah, it's very similar, but this one belongs to the third signal. This belongs to if it goes to 0 in a specific value, it will belong to 1. That makes sense to you? Okay. And the fourth thing, like signal of finite length that goes to infinite. If infinite length that goes to infinite. Which class? Yeah, class 3. Yeah, and okay. Any question about this one? Okay, yeah, you need to do the homework to practice. Yeah, there are some like signals you need to decide which classes do they believe. Okay, let's talk about the other quick facts about signal transformation. Okay, we talk about signal transformations, and there are 3 different signal transformations. What are those? Do you remember? Do you remember? 3 different signal transformations. Do you remember? Do you remember? Yeah, like the first one is shifting, time shifting, right? Delay or advance. Yeah, which like just like this. Okay, if the t0 smaller than 0, it's the left shift or right shift. Are you sure? If t0 smaller than 0. Are you sure? Which means like if this is for example, this is yeah, this is t x like t. This is x t, right? And x t minus t0. For example, t0 smaller than 0, which means t let us consider t0 equal -1. So the signal will become xt plus 1. Am I right? So which means if when here is 0, when the original one here is 0, which means this is 0, which means t equal -1. If t equal -1, and then this whole thing will be 0, am I right? So it will be this value, am I right? So which means if t equals -1, it will be this value. That makes sense to you? So then you can put the other value. It should be like this. That makes sense to you? So it's left shift or right shift? Yeah, it is a left shift. Yeah, just remember. Yeah, because here is this equation. If I give this equation, t plus t0, and then t0 smaller than 0, which means it will be right shift. But here I give you this equation, which means t0 smaller than 0, it will be left shift. Does that make sense to you? Yeah, yeah. I mean, you can see here xt. If t0 smaller than 0, which means if I let t0 equal 1, a -1, it will become this one, right? Yeah, which means if for the original one, if the whole thing is 0, for this one 0, t will equal -1. When t equal -1, this whole part will be 0, right? So which means t equal -1, it will have this value. That makes sense to you? For this step, am I clear? Because you can see when my for the new signal, if my t equals -0, -1, then what I got x0, am I right? What is x0? Here, am I right? So if my t equal -1, which means this value, this whole value equal -0 equal what? Equals this value. That makes sense to you? Yeah, so I just put this value here. That makes sense to you? Any questions so far? Any question? Okay, so which means it will be left shift. Am I right? Okay, if like obvious, if t0 greater than 0, it will be right shift. Let me show you. If t0 greater than 0, let us consider it is equal 1, which means it will be this equation will the new signal will become this one. Am I right? That makes sense to you? Yeah, if this one greater than 0, let us consider it is 1. Then the new signal is this one. Am I right? So for the if I let the t equal 1, which means this whole value should be x0. Am I right? Which means when t equals 0, when t equal 1, the value should x0. Am I right? So what is x0? It's here. So the equation should the new signal should be like this. That makes sense to you? So it will be right shift. That makes sense to you? Any questions so far? Okay. Yeah. And time reversal. What is time reversal? Time reversal. Flip. Yeah, flip. Yeah, flip respect to the y-axis. Yeah. So it's just like a positive become negative become positive like that. Okay. But the value is the same thing. Okay. Scaling. What is scaling? Yeah, shrink or the expanding. Like here. Okay. Which situation it will shrink? Which situation it will expanding? Do you know? Do you remember? Huh? Yeah. Like here, A, if it is smaller than 1, it will shrink or expand. Which one? Yeah, if it is greater than one, it will shrink. That makes sense to you? Okay. Yeah. So, but there are some like general like transformations, which means if it include shifting, reversal, and scaling together, and how can you do that? Do you remember if one signal transformations include shifting, time reversal, and scaling? There is a rule. Do you remember? Which one should be done firstly? Yeah. Just remember, always if you want to have a new signal based on the original one, and it includes the shifting, reversal, and scaling. And the first thing, always do the shift first. Yeah, and then scaling and reversal. Okay, this is just the rules for like signal general transformations. We talk about some examples in next class. Yeah, any questions so far? Okay, let's continue. Okay, let's talk about the other one example. Okay, there is an example like there is a signal xt, and with xt equals 0 when t greater than 2 or smaller than -1, like this. Yeah, this is the original signal. If the t is greater than 2 and smaller than -1, and the value will be 0. Otherwise, it will be 1. Okay, this is the original one. And let's talk about for a new signal, like this one. X, I want you to have the new signal. X negative, x1 minus t multiple x3t minus 1. Determine the range of t for which its value is 0. Okay, let's talk about that. Firstly, what's the first step for this one? Yeah, since it involves two different signals, we need to get the separate ones. I'm right. We need to get this one and multiply them together. That makes sense to you? Yeah. For the first one, x 1 minus t. What's the first thing we should do? What's the first thing for the signal transformations? Shifting. Am I right? So for the shifting, what like a t0 smaller t0 equal what? -1. Am I right? Yeah. So let me give you the steps, and I will now give you the answer directly. Yeah. So this is this is Q, and this is yeah T X T. Yeah, this is the original one, and for the X one. Yeah. So first, this is also we can write it like this. Am I right? Yeah, it's the same thing. Am I right? Firstly, we need to do the shifting. Here, when we talk about the shifting, we talk about t0. If it is smaller than 0, it will be left shift. Am I right? So here, what is t0 for this one? What is t0? For this situation, what is t0? Huh? Are you sure? If t0 equal 1, it will like this. So it is the same thing. It is the same thing. This is 1, this is -1. So which means the t0 should equal what? Yeah, just remember, you may be confused by this one. Yeah, but try to ignore this one before, because firstly, we need to deal with the shift. So just try to forget all the scaling, all the inversal. Yeah. So just try to try to focus on the shift. So we just focus this one. And this is the original equation we talk about. If t0 smaller than 0, it will be left shift. Am I right? So for this equation, and what is the t0? Yeah, it is -1. Am I right? If it is -1, we can. Am I right? That makes sense to you? We can write this like this. So it is +1 is +1 is +1. Am I right? So which means it is left shift by 1 unit. That makes sense to you? So left shift, which means left shift 1 unit. Okay. 1. It's just become this one. Am I right? It will look like a this is xt, and this is xt plus 1. Am I right? That makes sense to you? Plus 1. Because it will left shift with 1 unit. Am I right? And then we just do the inversal. For the inversal, negative plus 1. What does the inversal mean? Flip. Am I right? So it will along the y-axis flip. So then it will become flip means this one will go to this one, this one goes to this one. Okay, 1, 1, 2. Then this signal will become this one. That makes sense to you? Any questions so far? So then, yeah, it will become this one. That makes sense to you? Yeah, here it's just a 1 unit negative. This is 2. Am I right? Okay. Then we talk about the second one, this one. What's the first step? first step for if we want to get the x 3t plus 1? The first one is what? Shift. Am I right? So we need to do the shift is 1, like t plus 1. Am I right? So what's t0? Huh? T plus t0. What is t0? Huh? 1 or -1? Yeah, if you want this one, go to this one. What is that t0? Yeah, you can see if it is equal -1, it can be run like this, right? That makes sense to you? Yeah, so you need to pay attention. So which means left or right? Left, right? Because it's smaller than 0. Am I right? So it will left shift 1 unit. 1, 2, -2, 1. It will be like this, am I right? That makes sense to you? From here to here. Am I right? And then we do the what? Here, what's this? Yeah, shrinking like 3 times, like am I right? Like here, if it is 2, it's just it will shrink. That makes sense to you? Yeah. So it will goes like this. Let me see. Is it right?
Well, this negative one wouldn't be a redshift because you're subtracting the negative and making it positive.
Oh, sorry. I read it wrong. Yeah, here is it's active. Sorry. Yeah. So sorry, I thought it is, yes. Here is negative. I just read it positive. Here is minus. Oh, since here is minus, so what is t0? It is positive 1. Yeah, so it will be redshift. I'm right. Oh, okay. Redshift 1. 1, 2, 3. 3, and it's just like this. I'm right. Then shrink 3 times. It will go like this. Yeah. That makes sense to you? Yeah. So sorry, I just read it wrong. Okay. And then what is the new signal? Multiple them together. Am I right? So multiple those two together, what is this? And you can see for this one, it ranges from -1 to 2. Am I right? Here is just a 0 to 1. Am I right? So which means here is 0. Here is 0. If we multiple together, 0 area will be 0. Am I right? And 1 area should be 1. Yeah, 1 multiple 1 is just a 1. That makes sense to you? And then 0 multiple 1 is just a 0. So it should be like this. That makes sense to you? Any questions so far?
So you only want 5 for this instead.
Yeah. Yeah, because you can see other area is just 0. Am I right? If you multiple them together, it's still 0. That makes sense to you? Okay, let's talk about the other one. Yeah, so the like 0 area should be greater than 1 and smaller than 0. That makes sense to you? Okay, let's talk about this one. This signal x. Yeah, you can see those two is just the same with those two, but this is a plus. Now multiple. Am I right? So what's the result? If it is plus, which means you should plus those two together. Am I right? Am I right? Plus this one and this one. Am I right? What's the result? Plus, which means here is one area. One area plus 0 is 1. Am I right? And for this area, 1 plus 1 is 1. 2, and 1 plus 0 is 1. Am I right? So the final should be this one. That makes sense to you? Any questions so far? So, but the 0 area is just greater than 2 and smaller than -1. Am I right? Yeah, because here is just 1, here is 2, here is 1, here is others just a 0. Okay, any questions so far? Okay, yeah, let's continue. Let's talk about even and, oh, sorry, I just forgot, this is and, I will fix it. Even and odd signals. Yeah, have you ever heard this before? Even function and odd function. Have you ever heard this before? I think maybe in calculus or some class. Yeah, the even odd is just like the signals, the functions, like symmetrical respect to the y-axis. That makes sense to you? And the odd is just a symmetrical respect to the like original point. So this is like a typical even function. This is typical like odd function, right? And you know, like there is two very common signals, like a sin function. Sin function is even or odd function, right? Because it will symmetric respect to the like original point, right? And the cosine function is just like this. This is cosine function. So this is a typical even function, am I right? Yeah, this is cosine, this is sin. Okay, this is even function, and like odd function. And we can use the mathematical form to represent even function and odd function. Yeah, this is even. Like xt equal x negative t. You can see here is t, here is negative t, am I right? And the value should be equal. That makes sense to you? And for the odd, x negative t equals negative xt. Like yeah, because you can see x negative t is just like a negative xt. Opposite. That makes sense to you? Yeah, this is the odd function, mathematics form for the odd function. Okay. And then this is for the discrete signals. It's similar thing, just using the n replace the t. Yeah, any questions so far? Okay, let's talk about a very important conclusion. Yeah, like any signal, like pay attention here, any signal, no matter what signals you have, any signals can be breaking into a sum of an even signal and an odd signal, as this one. Yeah, like this is for the CT signals. Any signals can be represented as the even part and the odd part. And this is the even part. If we will have some homeworks like you to calculation the even part signals, and you can use this equation. Yeah, this is for the even part signals, and this is for the odd part signals. Yeah, because this is for the odd part signals. And let's talk about why any signals can be breaking into a sum of even signals and odd signals. Yeah, you can see here. If I add even signals and odd signals together, what I can do? What I can have? 2t plus x negative t plus half x t. I have this one, right? And then I have okay. Like if you add even part signals, even part and the signals odd part, you can have this one, right? And then what's this equal? You can see this is a half x negative t. This is negative half x negative t, which means those two parts should be removed. That makes sense to you? Yeah, because one is positive the other. And then these two parts will be left. And this is half xt. And this is the other half xt. What is it? It's active. That makes sense to you? It's just the original one, which means if you add the even part and the odd part, you can get the original one. That makes sense to you? Yeah, so that's the reason why any signals can be broken into a sum of an even signal and odd signals. And similar to the like DT signals. Yeah, you can use this equation to get the even part signals, and also using this equation to get the odd part signals. And then you can this is even part, this odd part. You add them together, you can get the original one. Yeah, that makes sense to you? Okay, let's talk about one example, like even odd. We have these equations, we have these signals, and let's talk about, yeah, this is even signals. This is even part signal. This is the odd part signal. Okay, for the even part signals, what is the even part for these signals? You know? Yeah, which means the original one plus the like inverse of the original one. Am I right? Yeah, this is x negative t. X negative mean, which means it just flip it like respect to the y-axis. Am I right? So you got this one. And then for this even part, you just add those two together and divide two. That makes sense to you? So you got this one. Yeah, because you just add together and here you should get this one. That makes sense to you? And then this is the even part. And this is for the odd part because you just use this one minus this part and divide two. So then you plus them together, plus those two together. You can see, yeah, this is the even part. This is the odd part. If you plus them together, you exactly can get this one. That makes sense to you? Yeah, so this is a improvement for like the conclusion we have here. Okay, and let's talk about the other one more question, one more example for the DT examples. Here, this is the original equation, original signals, xn. Xn is when n greater like 0, greater equal 0, it will be 1. Otherwise, it will be 0. And then we have x negative n. And here, this is the even part, even like equations. This is what we have. Yeah, like add these two and these two and divide two. And this is, yeah, for only for 0, it will be 1. Other, it will be 1 half, like a half. That makes sense to you? Yeah, and this is all parts. Yeah, you just use this one minus this one. And like for the 0, it will be 0 because 1 minus 1 is 0. And for this one, it's just like 1 divided 2, it is 1 half. This is negative half. That makes sense to you? Yeah. And then you add those two together. You will find you just get the original one. That makes sense to you? Any questions so far? Yeah, you add this part and this part, this even part and the odd part. You can see, you can get the original signals. That makes sense to you? Okay, and then you may have questions. Why we want to learn the even odd representation, or why we learn signals transformations? Actually, you can see, you can those two like things can help you to deal with some like signals. For the signals transformation, sometimes the original one is not that easy to deal with. You just try to shift it, try to scaling it, try to like inverse it, and then you will find out the new one is easy to deal with. And similar with the even odd, sometimes the original signals are signals are very complicated. Then you try to like do like a even odd composition, and then you will find a different part, like even part, odd part will be easier for you to deal with. Yeah, we will like use those in like later in some equations. Yeah. So that's the reason why we want to learn this here. Okay, any questions so far? Any questions? Okay, yeah. So let's talk about the most important thing we will learn in this class, the periodic signals. Okay, why we want to learn the periodic signals? You know? You know why we want to learn the periodic signals? Yeah, let's talk about the motivations. What is the motivation for us to learn the periodic signals? Let me ask you one question. Actually, I think I talked about this before. For the real world signals, do you think most of them are periodic or non-periodic? Yeah, yeah. And most signals, do you think it is non-periodic or periodic? Yeah. Are you sure? Yeah, actually, most signals in the real world are non-periodic, but yeah, some real-world signals can be roughly considered as periodic ones. Why? Yeah, because periodic signals are easier for us to deal with. You can see here, this is some heart rate signals, some body signals. Yeah, it's not like a strictly periodic signal. Am I right? You can see it's for different periodic. It's different. Yeah, but it has some rules. Yeah, but yeah, here it will be lower and then here lower. Yeah, it is not a strict periodic signal, but you can consider it as a periodic signals because it will easier for us to deal with. Yeah, that's the reason why periodic signals are very important for signal and systems. And you can also periodic signals offer useful properties to be studied mathematically and analytically. Yeah, because you can see non-periodic signals, sometimes it means there is no rules, am I right? But the periodic signals, which means there are some rules. Yeah, for the periodic signal, we can use some useful properties to be studied. Yeah, we will study all the properties later, yeah, in this class. Okay, and then periodic signals can be studied by some mathematical tools. For example, Fourier series. Yeah, we can try to use we can use the Fourier series to analyze periodic signals. Yeah, to get some useful information for us. For example, the low pass, high pass, and some band pass, abstract specific signals. Yeah, we want. Okay, and the non-periodic signals can be treated as one period of periodic signals. Actually, you can see some signals you cannot consider it is periodic signals. For example, this signals. Yeah, it has no rules. Yeah, but non-periodic signal can be treated as one period of periodic signal, which means the whole range is just one period, at least. Am I right? Yeah, you can find the periodic. Am I right? You cannot find a period, but you can consider it is just has one period. That makes sense to you? Yeah. Okay. This is the reason why we want to learn the periodic signals. Okay. Let's try to learn why we want to try to yeah. Before we learn periodic signals, let's review some facts. Let's review one fact. Any continuous periodic signals can be represented as a sum of sine waves or sinusoidal. It's just different name with different amplitudes and frequencies. Actually, we talk about it in the microelectronics. You can see any continuous periodic signals. Any continuous periodics can be represented as a sum of sine waves. Yeah, which means if your signals are periodic, you can represent your signals using a sum of sine functions. Am I right? Yeah. Then you will, if you learn in our following classes, you will learn many sine functions and also exponentials, exponentials functions. Yeah. you can see, let's review some math tips for the complex exponentials and sinusoidal signals. That's the reason why we want to focus on complex exponentials and sinusoidal function signals, because for the periodic signals, we can always use sinusoidal like several sinusoidal signals to represent this signal. And you can see the complex exponentials, it's just a sinusoidal signals. Why? Why? Do you know why? Because of one equation. Do you know what's that equation? Euler equation. You can see for the when you use Euler equation, you can easily to transfer the complex exponential signals to the sinusoidal equations. That makes sense to you? Yeah. So this one is like a Euler equations. Have you ever heard this before? I think you heard this before. Yeah. Just remember. Just like try to remember this. This is just like a one complex exponentials, and you can represent this complex exponential signals using sinusoidal signals. Using this, and this is just using this one. Yeah, this is just two very important equations you need to remember. And we call those two like a conjugate pair. What is conjugate pair? Have you ever heard this before? Yeah, actually, the conjugate pair is just not specific for those two. You can see if you have one complex value, like one is A plus B, G, the other is one minus B, G. These two, we just call it a conjugate pair. Yeah, do you remember that? Yeah, it's just a similar thing. Yeah. Okay, this is some mathematics we need to know. And then we have this one. This one equal this one. Why? From actually, why this equation we can have? You can see if we plus those two together, and these two will be removed. Am I right? Because the one is positive, the other is negative. Am I right? And then, which means 2 cosine this one and will equal this one plus this one, which means the cosine this one will equal 1/2 those one. That makes sense to you? Yeah. And the similar thing, the sine will equal this one. Yeah, because you can sin you just minus using this one minus this one, and then you can get this one. That makes sense to you? Yeah, if you use this equation to minus this one, and then you can get like yeah, these two will be removed. Am I right? And then this will equal 2g sin this part, and equal this one minus this one, yeah, this one minus this one, and then this one will equal 1/2g, like multiple this part. That makes sense to you? Yeah, and then yeah, this is a few like often used special case of complex exponential exponential functions. Yeah, e.g. this one equal this one equal one, this one equal this one, yeah, equal -1. Because you can see here, which means this part equal 2 pi cat. Am I right? So which means this equal cosine 2 pi cat plus j sin 2 pi cat. Cosine 2 pi cat, what does that mean? What is equal? It's just equal 1. Am I right? This one is sin 2 pi cat is just equal 0, which means you can remove this one. This one will equal 1. That makes sense to you? Yeah, similar with this one. Cosine, this one will equal 0, and here it's equal 1. Okay? Okay? Oh, no. This one is also equal like 0. This one should equal -1 because cosine pi equal -1. Am I right? So it will be equal -1. That makes sense to you? Yeah. So this is just to use like often used special cases. Okay. Let's talk about the CT, like a periodic signals. Actually, the CT periodic signals can be defined as this one. Does this make sense to you? ST equal XT plus capital T. Okay, let me ask you, what is capital? What is this capital T? What is this T here?
This is oscillation signal.
Yeah, but there is a specific name for the capital T actually. You can see it is called period. Does that make sense to you? Period. Which means if x t equal x t plus t. Yeah, which means if this is a signal, right? And this is a 0, and this is like a 2 pi. And your t should be 2 pi, am I right? Like which means 0 x0 should equal x2 pi equal t equal 0, t equal 2 pi, am I right? Yeah, so we call this one period. That makes sense to you? Okay. And then, yeah, this one. This is a continuous time period signal. What is a period? What is a period for this one? It's very obvious, am I right? Are you sure? There is no one. Yeah, it is t. Yeah, t. What is period? Which means from here to here. After this one, this is 1 period. After this one, it will be like continuous. It will repeat. Am I right? So you can see from this one, the duration should be t. Am I right? Yeah. So, yeah, how to find a unique period? The smallest positive value of t for which the above equation holds is, we call it fundamental period t naught. Actually, you can see this equation. You can consider t as a period. You can also consider 2t as a period. But the smallest positive t, we call it a fundamental period t naught or t0. Yeah. Okay. And let's talk about the periodic CT complex exponentials. Okay. The class of complex exponentials is defined as this one. Yeah. This is, we define complex exponential as this one. And then an important property of this signal is that it is periodic. Why? Why? Actually, we have a reason. Yeah, because this one can use, yeah, like a Euler equation to transfer it to the sinusoidal function. Am I right? Okay, which means xt, we can find a t. Am I right? Yeah, this one, which means this, we can find this one, and we can try to find this is equal 1 and make it as a period, and then we get this equation. That makes sense to you? Yeah. Yeah, because you can see these equations, because the x, since this is periodic, am I right? So we can find a capital T as a period, xt equal xt plus t, am I right? And xt plus pt, we can get this equation, am I right? This is xt, am I right? So if it is periodic, which means those two should equal with each other. So this part should be equal 1, am I right? So then we can get the here omega t equal pi 2 pi k. Why? Because here. That makes sense to you? Yeah. So this is, we call it the smallest. Yeah, because here we need to find the smallest. The smallest is just the when k equal 1, it is the smallest. So we call this a fundamental period, and the frequency, which means it's just like a 2 pi omega here, we call it fundamental frequency, because frequency, which means 1 over t0, right? Here it's 1 over, like 2 pi over omega 0. We call this omega 0 here, we call it fundamental frequency. We call this t naught is a fundamental period. Yeah, that makes sense to you? Yeah. So we will continue to talk about the CT, like periodic CT signals next class. Okay. Any questions so far? Okay.